So learning target 3 is only a little bit different from learning target 1 because if you look at number 1, it says I can create a table of values to graph the equation. And learning target 3 says I don't need a table of values. I'm just going to use the slope and the y-intercept. Okay? So I'm kind of pulling from last year's information that you learned about slope with Mr. Meeks. So you know if this was like a kind of a weak suit for you back then, really this is the time where I need you to kind of just do your best to make sure we understand this. So first thing I want you to know is slope-intercept form. And they call it slope-intercept form for a reason. Because just by looking at the equation, y equals mx plus b, you know the slope and you know the y-intercept. Okay? The y equals x kind of stays. It's the m and the b that kind of get replaced and that end up changing, right? So we're keeping the y and the x there. So we know that this is slope, right? You just took a quiz Friday on that, right? You got the equation solved for y, and then the number in front of x was slope every single time. So you know that slope stands for m. And we've talked about this, and again, we haven't done anything with it yet, but today we're going to talk for real about what the y-intercept does and how we use it to graph. Okay? So this is our y-intercept. Which means, if I would have, before today, given you this equation, like y equals 2x minus 1, and asked you to graph it, you probably will have thought, I'm going to make a table of values, I'm going to get a few points, probably like only, unless you remembered it from last year, so I would say, okay, when x is 0, 2 times 0 is 0 minus 1, y is negative 1. Let's make x 1. 2 times 1 is 2, 2 minus 1 is 1. Let's make x 5. 2 times 5 is 10, 10 minus 1 is 9. And then you plotted those points, right? That's a pain in the butt to do. Every single time you want to graph the equation of a line, you're going to make a table, do all that substitution, and then plot those points? No. So the point of using the slope and the y-intercept is you don't have to make a table. So maybe you just kind of put no more table. Now, can you use the table as like a fallback to kind of check yourself if you need to? Sure. Tables are very, very useful, but you can't use them all the time. Sometimes you just need a quick way to get that line down there. And that's what we're going to talk about today, okay? So, before we do that, I just kind of want to do a quick thing. I'm going to have you get your calculator out. And I'm just going to do a quick thing on the calculator with you and show you a few things about how to do some graphing. So see this button right here? See these gray buttons up here? You probably never had to use them before. But I want you to know how to use them for this. So I want you to hit the y equals button and clear out anything that's written in there just by using your, your little arrow keys here and then the clear. So go ahead and get me a nice clear screen. Does anybody see the words at the top, plot? None of them are highlighted like that. If they are, I need you to unhighlight them. You'll get an error. To do that, you literally just scroll up, hit enter, turns it off, and scroll down. So make sure none of your plots are on. Okay? So the next thing we want to do is check our window. Our window has to do with where, so hit, actually just hit graph right now. See this button right here, graph? Go ahead and hit that. And that pops up an empty coordinate plane, right? Does your coordinate plane go... Can you see all 4 quadrants? Okay, so I want to show you something. So this is 10, this is negative 10, this is 10, and this is negative 10. This is our standard window. So see this window right here, this button? I want you to hit window. And see this x min, x max, y min, y max? And then you have the x scale. That just means what do you want your... axis is to go by. Do you want them to go 1, 2, 3s? Do you want them to go 2, 4, 6 or 5, 10, 20, 5, 10, 15? So on your paper, just kind of do this real quick. Draw a quick little coordinate plane. And which of these 4 do you think is considered to be your x min? Your x min would be which of these 4? The north, the south, the west, or the east? Think of it as compass rose. X-axis is this one, so it's either this one or this one. Min means what's the lowest you want your x to go to? So wouldn't that be this? right? So this is my x min, which means this is my x max. So where would my y min and my y max be? You can guess. Your min means that's the lowest value you want your y to be, and this is your y max. I'm showing you this because when you set your window, it's really important, because what if I say, I don't want all 4 quadrants showing. I just want quadrant 1. I'm dealing with time and money. I don't need to have any negatives for right now. I want to get rid of this, this, and this, which means what would I want my x min to be? What was the farthest over I want my x to go? 0. What's the farthest I want my y to be? It's like restrictions on your domain and range, right? So I'm going to change my x min to 0. I'm going to change my y min to 0, and then I'm going to hit graph again. And they disappeared, right? They just kind of zoomed in on that first quadrant. Sometimes people like to get fancy and they like to be able to see a little bit. I kind of like this. You know, so I know I'm only using quadrant 1, but I still like to see the origin, and I still like to see those other quadrants. So that just kind of shows you, it's kind of like Google Earth, right? Zooming in and zooming out. So let's say you want to get your full standard 10, 10, negative 10, negative 10 window back, but you don't remember how. You don't want to go all the way to the window. So see this zoom right here? See this button zoom? Go ahead and hit zoom, and zoom in, zoom out, zoom decimal, zoom standard. So you want to hit zoom 6. Just hit the number 6. You don't need to scroll. So if you ever get to a window where it's not how you want it, zoom 6. Okay, there's so many functions that these calculators have that you guys have just been using them for like little simple calculations. So I'm trying to start to give you a little bit of idea of what these can do. Okay, so go back to your y equals. And I want you to just type y equals x. The x that we're going to be using is the one right next to the alpha button. Okay, so every time you need an x, that's the button you push. All right, so this is y equals x. This is our parent function. So when I hit graph, I want to see what that line looks like on a coordinate plane. So everybody have that line on their graph right now? Because we're going to play around with this a little bit. So this is y equals x, okay? So maybe in your notes, what you want to write is y equals x, and that's called the parent function. Okay? The only thing I can think of is they call it the parent function because that's where it all starts. This is where it originates from, because I want to ask you this. If you were to graph this, do you see a number after it? No. Do you see a number in front of the x? No, but when you don't see one, it's really a 1. So kind of y equals hidden in y equals x is a y-intercept of 0 and a slope of 1. Okay, I need you to know that. So in this, your y-intercept is 0, your slope is 1. Just kind of keep that in mind. Okay, so now we're going to talk about what happens when I put a number there. So go back to your graph, hit your y equals, and scroll down to y2, which means we're just going to graph 2 lines. And let's put y equals x plus 3. Okay, don't hit graph yet. What do you think is going to happen to that line? Because we want to talk about how this is affecting that. So what do you think, Isaiah?
It's going to move over right here.
Move what?
It's going to move like
What we're doing. Okay. Anybody have another guess? Allie?
It's going to move up by 3.
Okay, so it's either going to move over by 3 or up by 3. So go ahead and take a look at that and see what you think about. My screen is, hold on. It's so bright. Okay. So it moved up by 3. So, let me just get this a little, there we go, that's better. So what I want you to look at here is in y equals x, this 0 that I'm pointing at, the origin, is that 0 right there, right? So where does this go through the y-axis at? 1, 2, 3, and where do you see a 3 in your equation? So that's not a coincidence, right? So the fact that you have a plus 3 here is the reason why it's going through the y-axis at plus 3, right? So plus 3, plus 3. So go back and put x minus 4 and see what it does. Why is that shaking? Did it do what you expected it to do? It shifted what? Down 4. And down 4 from 0 is negative 4, right? So just kind of look real quick. I need you to see that negative 1, negative 2, negative 3, negative 4 is that negative 4. Got it? So right now we're not doing anything about graphing. I'm just kind of getting you understanding what the number after the slope means. That's your y-intercept, okay? So I'm going to pull mine away, and then you have to try to match mine. Okay. So we're going to do this thing where I show you my graph, and then you have to try to match yours to it, but I don't show you what I typed. So as soon as you get, and you're always keeping that y equals x in that first one. So try to figure out what you need to type in and show me your screen when you have it. That what you typed in to get that. What did you type in to get that? Hold your screen up when you have it. Okay. Oh, wait. No, I just want to see your screen. So you can clear out all your other ones. I just put in that in Y2. Good. Okay. Good. So what did you type in? To get it to shift down to, you typed in minus 2, okay? So why don't we point to this up here, and this takes control of our, we're going to call that a vertical shift. Okay, do you agree? I'm just kind of shifting that line up and down. That's what the number after y or x, it's called your y-intercept. It's called an intercept because that is where the line intercepts or touches or intersects the y-axis, right? Okay, so go back into your y equals, clear out this, and now let's kind of discover what it does when we put a number in front of the x, meaning we give x a coefficient. What number is in front of the x right now? 1, right? And you understand that that means up 1 over 1, up 1 over 1. It's like your standard box set of steps. Up 1 over 1. So from this right here, I'm at the origin, and my slope is up 1 over 1. Up 1 over 1. That's what that y equals x equals. Okay, so let's put in y equals 2x. Now, don't touch anything. Don't hit graph yet. Let's have some guesses. What do you think that's going to do? Is it going to go through the origin? Is it going to shift up or down at all? Is this line going to shift up or down? But what else is going to change? Amelia, got it? Something? What else? How does it change? Go ahead. Okay, it's going to get steeper. So something I probably should have said before, when I had you type in y equals x minus 5, y equals x plus 2, what you noticed about all of these lines is that they were all what to each other? Parallel, right? They were all parallel. They were never going to touch, ever, 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 because I didn't mess with this part of it. I didn't change the steepness at all. I just changed where it was in terms of up and down. Because look, what number's in front of all of my x's? 1. So then the slopes are all the same. Guess what learning target? I can write equations of parallel lines. Well, there you go. When the slope's the same, they're parallel. We're going to get to that. So watch what happens right away when I change this. Go ahead and hit graph. Did you have a question, JC?
No,
So it took my original y equals x. It's still going through the origin. It just made it steeper. Make it steeper still. Type in another coefficient. If that's 2x, what would 5x look like? So play around a minute. Yeah. Some of them start to get so steep they almost start to look vertical. But we know they're not, right? So I put in 5x. So this black line is 5x. See what 10x looks like. I could still go a little more, right? So do you understand that the number in front of the x is the slope, and the bigger you make it, the steeper it gets, okay? Now, stop for a second. Everybody, I need your eyes up here because I want to kind of show you why it works that way. So on this coordinate plane, if I am here and I go up, because I know when my slope is 2, it means I go up 2 and over 1, right? Because when your slope is 2, it doesn't give you the run, but you know that it's 1, right? So here's up 2 over 1. Well, what would a slope of 3 look like? It means instead of going up 2 and over 1, I'm going to go up 3 and over 1. Yeah, that's why it's steeper. Now let's go up. So here's this. Let's go up 5 and over 1. So up 5 and over 1. So do you see why it's steeper every time still? Okay. So if y equals 3x and 5x and 10x makes it steeper, what do you think I can put to get this line? Not that one, but it's not what you think. Play around a minute. Try to get your line to match that one. What would you type in? I'm not going to show you yet. But what do you think I typed in? I know your original thought is probably, oh, make it negative then. There's a lot of numbers that are less than 1 that are negative. What kind are they? That was a huge hint. What kind of numbers are less than 1 but not negative? Yes. Fractions, right? Fractions that are proper, meaning they're less than 1. So, give it a shot. Do you know how to type in a fraction, right? The divided by is the fraction bar. So what fraction do you think I have? I just chose the standard one.
1/2.
Yep. So 1/2 x. So 1/2 is equal to 50 cents, right? Let's do 33 cents. So what do you think? That's going to be even less steep than the 1/2, right? So play around with that for a minute. See how less steep you can get it without it almost actually looking horizontal. I mean, these are pixelated calculators. And remember, my window's only 10, 10, negative 10, negative 10. What if I made it negative 100, 100, negative 1? Like, that would mean just I Google Earthed, I zoomed it out, right? So they wouldn't look as horizontal as they look right now. This one does, okay? So, compared to the blue line, do you guys kind of have an idea of what the number in front of and after x compares? Okay, so now try to get this. That's my y equals x. And some of you thought about it earlier when I asked you to do the left steep. This is what you would do now. Okay, show me your screen. Yep. Hold your screen up when you got it. You do not use the minus sign, right? Okay, so what did you type in to get that? Negative. So you know negative. Look at this poster right here. See how it says negative? Looks like the end that's going down. You need to know that it makes it going down. Okay, so now I'm going to combine them all. Ready? I need you to try to match the sign. Okay. That's my original, my parent function. Right through that. So, what would you type in your calculator to match that line? Show me when you got it. You have to know that not only did it shift up a certain amount, it also got less steep. Right? So hold your screens up when you got it. Really requires some thinking, doesn't it? So I combined both shifts. I shifted it up. Where is it touching the y-axis at? 4. So what should be at the end of your equation? Plus 4. Now you just have to figure out what's at the beginning in front of the x, because that controls the steepness. Good. Good. If you have it and the person next to you does not, maybe help guide them through what they could do to get that line. And I'll say this right now. Is there any way to know my exact fraction that I chose? No. The important thing is that you know that it's a fraction and not a whole number, right? Okay. I chose 1/3 plus 4. Anybody else got that? If you have a half, is it the idea is close enough? Yes. Okay. Ready? Try to match this one. I did all 3. So I flipped it. I made it a little steeper. And I shifted it down. Okay, so where is it touching the y-axis at? -3. So I know there's going to be a something x minus 3, right? And then that something is negative, so it's going to be a negative coefficient, whatever it is, and it's a little steeper, so let's just say that. Does anybody have that exactly? -2x minus 3, okay? All right, so that just kind of gives you, somebody says, what would happen, don't graph it yet, if you accidentally forgot the x and just hit enter?
Oh, I did that.
And what did you get? What kind of line did you get? Well, they're all straight. Everybody says that. A horizontal, right? Because you forgot the x, and then you hit graph, you had your parent function, and then you had a horizontal line going through 5, and then you were like, what? Why is it doing that? Because this is really what you typed in when you typed that in. You typed in 0x plus 5, right, basically? Because when you don't include an x, you're saying that your slope is 0. So that's the same as that. And we know that the slope of every horizontal line is 0. If the x has a coefficient of something other than 0, you know it has some kind of slope to it. Okay? All right, good. So now